Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of a solid into which the front view face, the top view face and the right hand side view face of the solid, they have been appropriately clubbed into a single 3D isometric projection over here. So using the information available with us through this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections corresponding to this engineering object. So in order to evaluate the orthographic projections of the solid, we are required to obtain the dimensions of the front view face, the top view face and the right hand side view face of the solid. So when we are going to look at the solid from the front view orientation, we observe that the width of the solid happens to be 115 millimeter while the height of the solid happens to be 50 millimeter. So the front view face dimensions corresponding to this object will be 115 by 50 millimeter. Similarly, when we are going to look at the solid from the top view orientation, so we observe that the width of the solid, it is 115 millimeter while the depth of the solid happens to be equal to 60 millimeter. So the top view face of the solid will be having the dimensions 115 millimeter by 60 millimeter. And when we are going to observe the solid from the right hand side view orientation, so we find that the depth of the solid happens to be equal to 60 millimeter while the height of the solid is equal to 50 millimeter. So the side view face of the solid will be having the dimensions 60 millimeter by 50 millimeter. So with this information, we are required to obtain the orthographic projections of this engineering object. So here we have drawn the XY reference line and the X1, Y1 reference line. And we have also obtained a transfer line which is starting from this origin point, that is the intersection of the XY and the X1, Y1 reference line. And this transfer line happens to be inclined with respect to XY reference line at an angle of 45 degree over here. So this transfer line will be used to transfer the distances from the top view alongside the depth orientation into the right hand side view orientation over here. So since we are going to obtain the orthographic projections of the solid into the first angle projections, so the front view projections will be obtained above the XY reference line. The top view projections of the solid will be obtained below the XY reference line and the right hand side view projections of the solid will be obtained on the left hand side of the front view projections over here. So now when we look at the solid from the front view orientation, so we know that the width of the solid happens to be equal to 115 millimeter. So here we have marked this width of the solid equal to 115 millimeter into the front view projections by drawing two vertical projector lines which are separated by the distance 115 millimeter, and these two vertical projector lines we have extended them into the top view projections as well, because into the top view projections also the width of the solid will be required as 115 millimeter over here. And now we know that into the front face orientation, the height of the solid happens to be equal to 50 millimeter. So we have marked this height of the solid equal to 50 millimeter by drawing a horizontal projector line at a height of 50 millimeter above the XY reference line into the front view orientation over here. And this horizontal projector line again has been appropriately extended into the right hand side view projections over here, because into the right hand side view projections also we are required to obtain height of the solid equal to 50 millimeter. Now we know that the depth of the solid happens to be equal to 60 millimeter. Now we have marked the depth of the solid equal to 60 millimeter into the top view projections by drawing two horizontal projector lines which are separated by the distance equal to 60 millimeter into the top view projections over here. And these two horizontal projector lines we have appropriately transferred into the right hand side view projection view, such that into the right hand side view projections we have obtained depth of solid equal to 60 millimeter and height of solid it is equal to 50 millimeter. This way we have been able to obtain projections corresponding to the front view face, top view face and the right hand side view face into the orthographic projection views over here. So now when we are going to closely look at this particular solid, now we find that we can divide the solid into two elements over here. So the element number 1, it happens to be a horizontal web. We can check, this is a horizontal web which is lying onto the base of the solid, and the dimensions of this horizontal web, it happens to be 115 millimeter, it is the width, 60 millimeter, it is the depth, and 25 millimeter, it is the height of this element number 1. Then on the top of this element number 1, again we have got another horizontal web over here. So this is another horizontal web which is located towards the left hand side portion of the solid over here. So into the left hand side portion of the solid, so another element number 2, which is another horizontal web, it is placed above the element number 1, which was again a horizontal web which was resting onto the ground. Now the special characteristic of the second horizontal web which is located onto the left hand side portion of the solid, it is that into this horizontal web we have got two vertical elements over here. That is, there are two vertical webs which are integrated on top of this horizontal web over here, and these two vertical webs which are mounted on top of this horizontal web, they are lying towards the front face of the solid and the rear face of the solid over here. And into these two vertical webs we have got rectangular slots located at the center of the web at the top face of the solid over here. So this way we have got element number 1, which is a horizontal web into which a rectangular slot has been cut at the base of the solid, and another rectangular slot has been cut towards the right hand side portion of the solid over here. So let us start with the construction of the orthographic front view projections corresponding to these two elements, that is element number 1 and element number 2. So now we know that corresponding to element number 1, we have got a rectangular slot located at the base of this solid over here, and this height of this rectangular slot happens to be equal to 12 millimeter. So we have marked a distance of 12 millimeter from the base and drawn a horizontal projector line at a distance of 12 millimeter from the base in such a way that we have extended this projector line appropriately into the right hand side view projection view over here. Similarly, next thing we know that into this element number 1, after the cutting of this rectangular slot, now we have been provided with this width of the leg of the solid onto the left hand side. Again, this width of 15 millimeter of the second leg of the solid is there, which is available onto the right hand side of the solid. So corresponding to leg number 1, we have got width is equal to 15 millimeter. So at a distance of 15 millimeter from the left hand side face, we have drawn a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view projections as well. Similarly, corresponding to the second leg of this horizontal web of the solid, now we have got the width of the second leg as 15 millimeter once again. So now we have marked a distance of 15 millimeter width from the right hand side face of the solid, and we have drawn a vertical projector line into the front view projections, and we have appropriately extended this vertical projector line into the top view projections over here. Next, we have got corresponding to this element number 1, that is this horizontal web over here, we have got the height of this horizontal web equal to 25 millimeter. So now we have marked the height of the horizontal web as 25 millimeter, and we have obtained at a height of 25 millimeter from the base another horizontal projector line into the front view projections, and we have extended this projector line into the right hand side view projections over here. Now next we have got this particular dimension, that is, we know that there is a rectangular slot available into this horizontal web which is located towards the right hand side portion of the solid. So now we know that this square web, it is going to start after this particular distance, that is after a distance of 15 millimeter, that is this particular portion of the solid. We know that this square rectangular cross section, it is available at a distance of 35 millimeter from this surface of the solid over here. So we have already marked this distance of 15 millimeter over here. So now from this face, we have marked a distance of 35 millimeter towards the left hand side portion of this particular solid, and now we are able to obtain another vertical projector line corresponding to this rectangular slot which is available into the top surface of this horizontal web, that is element number 1 over here. And this vertical projector line also we have extended it into the top view projections as well. And now we know that this horizontal portion of the element number 1, it is going to continue up to a height of 25 millimeter till we are able to reach at a point 65 millimeter from the right hand side face of the solid. So this is the right hand side face of the solid. So at a distance of 65 millimeter from the right hand side face of the solid, so we'll be able to obtain this particular edge of the solid up to which the height of the horizontal web will be equal to 25 millimeter. So now we have marked a distance of 65 millimeter from the right hand side face of the solid, and again we have drawn a vertical projector line into the front view projections. Now we have extended this vertical projection into the top view projections as well. Now another thing we know that into this particular second element, that is horizontal web number 2. So here we have got the second element or another horizontal web into which there are two vertical webs which are integrated at the top surface of this horizontal web, and into this vertical webs, one of the web, it is available onto the front side of the solid, and the second vertical web, it is located towards the rear side of the solid over here. So into these two vertical webs, here we have got a rectangular slot at the middle of the web. So at the middle of the web, the depth of this rectangular slot has been provided to us as 10 millimeter. So now we have marked this distance of 10 millimeter from the top face of the solid, and corresponding to this depth of this rectangular slot which is available onto this vertical web over here. So we have marked a horizontal projector line into the front view projections at a distance of 10 millimeter from the top face, and we have extended this horizontal projector line into the right hand side view projections over here. Now we know that into this vertical web we have been provided with the dimensions of the square blocks which are available on either side of this vertical web over here, right? So next to this rectangular slot we have got two vertical square blocks over here. So the dimensions of square block is 12 by 12 millimeter and the height is equal to 10 millimeter. Now we can observe that the total width of the solid happens to be 115 millimeter and the total width of the solid alongside element number 1, it happens to be 65 millimeter. So this width of the solid corresponding to the second horizontal element, it happens to be equal to 50 millimeter. So out of this total width of 50 millimeter corresponding to element number 2, 12 millimeter is the dimension of the square block on the left hand side. 12 millimeter is the width of the square block which is appearing onto the right hand side. So this distance of the rectangular slot, that is the width of the rectangular slot, happens to be equal to 26 millimeter. So now we can check. We have marked two vertical projector lines corresponding to element number 2 such that these distances will be 12 millimeter width corresponding to first vertical block, 12 millimeter corresponding to the second vertical square block, and 26 millimeter corresponding to this rectangular slot. So now we have obtained two vertical projector lines which we have marked with the help of orange color projections into the front view projections and the top view projections over here. So now another thing we know that there is a horizontal surface which is available corresponding to this element number 2 over here, which is a horizontal wave, and now this surface is available at a distance of 10 millimeter from the top surface of element number 1, or it is available at a distance of 15 millimeter from the top surface of the solid. So now here we have marked a distance of 15 millimeter from the top surface of the solid, so that this horizontal surface corresponding to this element number 2 we are able to locate into the front view projections over here. So once we have marked this distance of 15 millimeter below the top surface of the solid, we have drawn a horizontal projector line into the front view projections at a distance of 15 millimeter from the top surface, and we have extended this horizontal projector line into the right hand side view projections over here. So let us now obtain the projections corresponding to the edges which are visible to the observer from the front view orientation over here. So as the observer is going to look at the solid from the front view orientation, we can check this vertical edge will be visible to the observer. This horizontal base edge corresponding to the first leg of the solid will be visible to the observer. This rectangular slot will be visible to the observer, and the base corresponding to the second leg of the solid will be visible to the observer. And then this height 25 millimeter corresponding to element number 1 will also be visible to the observer. So this way all these edges which are visible to the observer corresponding to element number 1 we have been able to join with the help of object lines. Now we can check this portion and this portion. So this portion of the solid, it will also be visible to the observer. So now we can check. We have marked corresponding to this vertical element, a rectangular slot is available over here. So this rectangular slot is having width 26 millimeter, height is equal to 10 millimeter. Similarly, corresponding to this vertical block, we have got width is equal to 12 millimeter over here. So this way we have been able to join this portion of the solid which will be visible to the observer from the front view orientation over here. Now from the front view orientation, this horizontal surface, it will not be visible to the observer because this horizontal surface has been covered by this vertical web which is located towards the front face of the solid over here. So that is why corresponding to this horizontal surface, we will be able to obtain the hidden line projections or the dotted line projections at a distance of 15 millimeter from the top face, because this dimension happens to be 15 millimeter from the top face of the solid over here. Similarly, this vertical face and this vertical face, so these two vertical faces corresponding to this rectangular slot, they will also not be visible to the observer from the front view orientation. So now corresponding to this width of 35 millimeter, we can check this width happens to be 35 millimeter. So corresponding to this width of 35 millimeter, so corresponding to these two vertical faces, we are able to obtain hidden line projections corresponding to this rectangular slot being obtained into the front view projections over here. This way we have been able to obtain the front view orthographic projections of the solid. Now into the top view projections, we know that towards the rear face of the solid, this is the rear face of the solid, we have got a vertical web on top of this element number 2, which is having depth is equal to 12 millimeter. So corresponding to this distance of 12 millimeter corresponding to the rear side web, now we have marked a horizontal projector line at a distance of 12 millimeter from the rear face of the solid, and this horizontal projector line has been appropriately transferred into the right hand side view projection view over here. Similarly, towards the front face of the solid, again there is a vertical web which is having depth is equal to 12 millimeter. So again we have marked the depth is equal to 12 millimeter from the front face of the solid, and we have been able to obtain a horizontal projector line at a distance of 12 millimeter from the front face into the top view projection, and this horizontal projector line has been appropriately transferred into the right hand side view projections over here. Next we know that corresponding to this rectangular slot, so we have been provided with the information that the total depth of element number 1 happens to be 60 millimeter, while this slot having dimensions 30 millimeter by 35 millimeter, it has been located centrally on top surface of this element number 1 corresponding to this surface of element number 1. So now we can check that this rectangular slot is going to start at a distance of 15 millimeter from the rear face of the solid, and it will be starting at a distance of 15 millimeter from the front face of the solid, so that the total depth of the slot, it should be equal to 30 millimeter. So what we are going to do now, from the rear face at a distance of 15 millimeter, we have obtained a horizontal projector line corresponding to the slot, and we have transferred this horizontal projector line appropriately into the right hand side view projections over here. Similarly onto the front side also, so from the front face of the solid, we have measured a distance of 15 millimeter corresponding to this edge of the rectangular slot in the element number 1. So again we have drawn a horizontal projector line at a distance of 15 millimeter from the front face of the solid into the top view projections over here, and we have transferred this horizontal projector line into the right hand side view projections over here. So now we have been able to obtain this rectangular slot into the top view projections over here. So now let us join all the edges which are visible to the observer from the top view orientation over here. So when the observer is going to look at the solid from the top, this boundary of the solid will be visible to the observer from the top view projections over here. Next we have got corresponding to this element number 2. So this boundary corresponding to the web number 2 or the horizontal element number 2 will be visible to the observer. So this way we can join the front face and the rear face over here at a distance of 65 millimeter from the right hand face, or at a distance of 50 millimeter from the left hand side face over here. And now we know that there are two vertical webs, one vertical web at the rear side and one vertical web at the front side of the solid over here, which is carrying the rectangular slot at the middle of that particular vertical web. So now we can see that corresponding to this vertical web at the back side, we have got 12 by 12 square vertical block on the right hand side of this element number 2. There is a square block 12 by 12 onto the left hand side of this vertical web over here on the rear side. Similarly, there is a 12 by 12 square block projection onto the left hand side. Again, there is a 12 by 12 square block projection which is corresponding to this square block onto the right hand side. And this is the dimension corresponding to the rectangular block. So this is having 26 millimeter width and 12 millimeter depth of this rectangular slot over here. So corresponding to these 4 square blocks and these 2 rectangular slots, we have been able to obtain true shape projections corresponding to each one of these elements into the top view projections over here. Similarly, corresponding to this rectangular flat surface, which is the top surface of the element number 2, we have been able to obtain the true shape projections into the top view projections over here. Next, we have got this rectangular slot available over here. So now, having obtained the boundaries of this particular rectangular slot, we are able to obtain the true shape projections corresponding to this rectangular slot as well as this horizontal surface which is lying on top of this particular element number 1, which is a horizontal web over here. Now, corresponding to this vertical surface of the rectangular slot and corresponding to this vertical surface of this rectangular slot which is available at the base of the solid, now we'll be able to obtain the dotted line projections on the right hand side, and we'll be able to obtain dotted line projections on the left hand side at a distance of 15 millimeter from the right hand side face and 15 millimeter from the left hand side face. So this way we have been able to obtain the top view projections corresponding to the solid. Now when we observe the solid from the right hand side view orientation, now we observe that we'll be able to see this portion of the object over here. So this way we are able to obtain this particular rectangular groove at the top over here. So now we can check, this is a rectangular groove which will be visible to the observer. And what are the dimensions of this rectangular groove? We can check 12 millimeter on this side, 12 millimeter on this side. So this distance is 12, this distance is 12. That makes it 24. So the remaining distance out of 60 millimeter, so this distance will be equal to 36 millimeter. So this distance will be 36 millimeter. This height, it is equal to 15 millimeter. We can check. This horizontal surface is available at a distance of 15 millimeter from the top surface of the solid. Another thing we will be observing, corresponding to this surface or corresponding to this surface at a height of 25 millimeter. Now a horizontal edge we will be able to observe corresponding to this surface of the solid. Now next we can observe that corresponding to this rectangular slot, because we know that the height of this rectangular slot happens to be 12 millimeter. So at a height of 12 millimeter, a dotted line or a hidden line projection will be visible over here. So corresponding to this rectangular slot, we are able to obtain dotted line horizontal projections into the right hand side view projections over here. And again, corresponding to this vertical face and corresponding to this vertical face of this rectangular slot into the element number 1, we will be able to obtain hidden line projections into the front view projections over here. So into the front view projections, we will be able to obtain hidden line projection. And now we can check, we haven't marked this hidden line projection up to the base. Why? Because this slot was available up to the height of 13 millimeter, because the total height happens to be 25 millimeter, whereas this slot is available up to a height of 12 millimeter. So into this solid element which is having height is equal to 13 millimeter, we have marked this dotted line projection only between these two cross sections only. And finally, corresponding to this horizontal surface and corresponding to this horizontal surface, because this surface and this surface, they will not be visible to the observer from the right hand side view orientation. So again a dotted line projection over here, again a hidden line projection over here will be visible to the observer, and this is visible to the observer at a distance of 10 millimeter from the top. So we can check, this is 10 millimeter distance from the top where this rectangular groove has been obtained over here into the front view projection. So into the side view projections, so this dotted line projection will be available at a distance of 10 millimeter from the top surface of the solid over here. So this way we have been able to obtain the orthographic front view projections, orthographic top view projections, and orthographic right hand side view projections corresponding to an engineering object, corresponding to which a 3D isometric projection view was available with us. So this is all for today. We'll be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.